Welcome back everyone to another video here on the Unknown Coder YouTube channel. Today we are back with another LeetCode video. Today we are doing 905, sort array by parity. This is a little bit more of a confusing array problem, but what it's going to say is it's going to give us an integer array called nums and then move all the even numbers at the beginning of the array followed by all the odds. So the name of this makes it a little bit confusing, but it's basically saying sort all the evens at the beginning and sort all the odds at the end. Now something special about this problem is there's actually multiple answers to each one. As you can see here, it says return any array that satisfies this condition. So this means that there's possibly multiple different examples or multiple different solutions. So your mileage may vary on this, but as long as all of your odds are at the end and all of your evens are at the beginning, it should be completely fine. Today, I'm going to do things a little bit differently. I don't see any value in looking at example number 2. So let's go ahead and take a look at example number 1, and then we'll hop back over to our constraints. So for example number 1, we're going to have an input of nums equal to 3, 1, 2, and 4. And our output is going to be nums equal to 2, 4, 3, and 1. So it shouldn't be too hard to realize why this is. So basically 2 will be the first even, so we want in that one. 4 is the next even, and then the first odd is 3, the second odd is 1. So this is just the relative order that I came up with, or it's one of the ones that they came up with as well. It doesn't matter which order they're in, just because all they care about is making sure that the first numbers are even and the last numbers are odd. Let's go ahead and hop over to our constraints and make sure we can't get anything else out of them. So for this problem, our constraints are pretty vanilla. The first one being 1 is less than or equal to nums.length is less than or equal to 5,000. All this is saying is that the length of nums is between 1 and 5,000. This is still a relatively small array compared to other ones, so if you need to try to brute force and use multiple loops, it should still technically pass. However, you shouldn't have to deal with that. Also, it's saying that there's at least one value in there, so we don't have to worry about checking for a null array, which is also nice. The next constraint is 0 is less than nums of I is less than or equal to 5,000. Once again, this is very simple. This is just saying the values inside of nums are going to be between 0 and 5,000. Again, this one doesn't really affect us much because negative numbers are still even or odd. So even if there would have been really small numbers, it wouldn't have been that big of an issue. So we didn't really pull that much more information out of here other than knowing that we can if we wanted to do a brute force algorithm. So as we mentioned above, our goal is going to be check whether or not the current value inside the array is an even number or an odd number. And then if it is in fact an odd number, we want to go ahead and shift that to the end of the array and make sure all of the even numbers are shifted to the front of the array. So this problem does not actually state for us to modify the array in place. However, it's not any more difficult to actually modify it in place rather than create a new array. So we're going to go ahead and save a little bit of space and just modify it in place anyway. We're going to use another counting system similar to some of the other problems that we've already solved. And this is going to be to keep track of the last index of our even numbers and also know where to put the odd numbers whenever we're going through. So let's go ahead and take a look at our pseudocode to try to clarify some things before we walk through our example. So for this pseudocode, we're going to start with even and current equal to 0. We're abbreviating these. Even and current are basically standing in for index, but I want to abbreviate things. Then we want to say while the current index is not the end of nums. So while we haven't reached the end of nums, we want to check if the value at the current index is even. If it is even, we want to go ahead and swap the values at current and the even index. Then we want to go ahead and increment the even index and the current index. Then we need to go ahead and check if the value we placed at the current index is also even. If this is the case, we want to make sure we go backwards one index so we can also place that at the front. Then once we're done with all this, we'll go ahead and return the array. Now, it might not seem like much, but it does actually work. So let's go ahead and take a look at the example so I can prove that. So once again, our example, we're going to have nums equal to 3, 1, 2, 4. And we're going to start out with I equal to 0. Our current is going to be equal to 0. Our even will be equal to 0. Then our nums of current is equal to 3. So 3 is not even. We want to increment current to move on to the next step. I is equal to 1. Our current will now be equal to 1. Our even is equal to 0. And our nums of current is equal to 1. Once again, 1 is not even. So we're going to go ahead and say current plus plus. For I equal to 2, current is equal to 2. Even is still equal to 0. And our nums of current will now be equal to 2. Now we have an even number. We want to swap nums of even and nums of current. So now nums of 0 will equal to 2, and nums of 2 will equal to 3. And we need to go ahead and increment even and increment current. Iteration I equal to 3. Our current is now equal to 3. Our even is equal to 1, and our nums of current is equal to 4. Once again, 4 is even, so that means we're going to go ahead and swap nums of even and nums of current. So now nums of 1 will equal to 4, nums of 3 equal to 1, and we need to go ahead and increment both. This will be the end of our loop, and now our nums will be equal to 2, 4, and 3, 1. Nice and simple. Let's go ahead and hop onto LeetCode, take a look. First thing we need is an integer array called even, and we'll set that equal to 0. We'll say for int I is equal to 0, I is less than nums.length, and I++. And in here, we'll say if even is not equal to our current index, and our nums of I mod 2 is equal to 0. If this is the case, we'll go and swap. So int temp is equal to nums of even plus plus is equal to nums of I, and then nums of I is equal to temp. We need to check to make sure temp wasn't even to start there again. So if our temp mod 2 is equal to 0, then we want to say I minus minus, and at the end of this, we'll return our nums, and hopefully I didn't typo again. Let's try it. There we go. It says that there's a 0 millisecond runtime, but I've copy and pasted it. It doesn't actually, just 0 milliseconds. It doesn't work. So this is how you beat 99.97% of runtimes here on LeetCode. As always, if you guys did enjoy or you found this was valuable, please leave a like, comment, subscribe. Everything helps out. And as always, this has been Ethan, the Coder. Peace out. Have a great one. I'll see you guys in the next video.